Let's look back at the previous example that we have solved. This is an exercise we looked at in a previous video. And the idea was that we were given information about two bowling balls that were heading towards each other, and they simply bounced off of each other after the collision. Now, one thing I want to note is the given in this question. So we were given 5 things. We were given the mass of object A, the velocity of object A, the mass of object B, the velocity of object B, and the velocity of object A after the collision. So the purpose of this video is to let us see a way or find a new way in order to solve questions where this velocity is not given. And this would be extremely powerful because if velocity of A after the collision is not given, then this means we are able to solve questions based on only the information given before the collision. So this is extremely powerful because then you are able to predict correctly the velocities of both object A and object B after the collision, even though you only have information about the collision before it happens. So this is the goal here. The goal would be to solve exercises where we're only given information about the two objects colliding before the collision itself. So this extra piece of information would no longer be given in questions. If it is given, then great. You solve the exercise like this, and that would be the end of the story. But what if we are given only the information before the collision even happens? So let's look at that scenario for a moment. Let's see what happens to the formula. So in fact, the formula for the conservation of momentum stays the same. We know that the momentum before the collision is equal to the momentum after the collision. So the mass of A times the velocity of A plus the mass of B times the velocity of B is equal to the mass of A times the velocity of A after the collision plus the mass of B multiplied by the velocity of B after the collision. This is not a surprising story. We already know this, we've seen this before. But this will not be sufficient to solve the exercise if we are only given information before the collision happens. We need another formula. So we will be using this one, but we need something else. We need a new thing, a new formula, a new given that allows us to solve this problem. And that is the conservation of energy, particularly kinetic energy. So what is that? Similar to the conservation of potential energy, of momentum, the conservation of kinetic energy will look something like this. Ke is equal to Ke prime. And again, this means that the kinetic energy before the collision is equal to the kinetic energy after the collision. So let's look at the kinetic energy before the collision. What is it equal to? It is equal to the kinetic energy of A, let me fix that, the kinetic energy of ball A plus the kinetic energy of ball B. And we can expand this even more. The kinetic energy of A is equal to half MAVA squared. And similarly, the kinetic energy of B will be half MBVB squared. So let's expand this even more. Let me remove this out of the way. And we can expand this even more and say that the kinetic energy before the collision is equal to half MAVA squared plus half MBVB squared. Similarly, the kinetic energy after the collision is equal to the kinetic energy of A after the collision plus the kinetic energy of B after the collision. And this is going to be equal to half MAVA prime squared plus half MBVB prime squared. So now we have an expanded form of what the kinetic energy is before the collision and an expanded form of the kinetic energy after the collision. And given that this is equal to this, then this must mean that this is equal to this. So let's write that down. So half MAVA squared plus half MBVB squared is equal to half MAVA prime squared plus half MBVB prime squared. And this is the conservation of energy. We're going to use this now in order to solve this problem. So KE is equal to KE prime. This is the other form of, or the other part of the solution. So we're going to use this conservation of momentum in combination with the conservation of energy to solve our exercises. So in the next video, you're going to see an example of how we're going to be using these two formulas in combination with each other to solve such a question where you're only given information about the collision before it happens.